The first type of energy that we're going to look at is kinetic energy. This is the energy due to motion. So if you think about an object that's moving, what distinguishes the energy of that object is a couple things. How much mass does the object have? The more mass that you have, the more kinetic energy you'll have. And then how fast is it going? So we calculate kinetic energy by multiplying 1/2 times the mass in kilograms times the speed in meters per second. It's speed because energy is a scalar, and so there's no direction with energy, and the unit is the joule for kinetic energy. So we're going to start out with this sample problem. What is the kinetic energy of an 11 kilogram bowling ball rolling at 4 meters per second? And then what would the velocity of a 0.624 kilogram need to be to have the same kinetic energy as the bowling ball? So why don't you go ahead and work this through. Just draw a simple picture first like this, and you can work through. Go ahead and pause the clip, and then when you're ready you can continue. Okay, so you should have gotten 88 joules for the kinetic energy of the bowling ball, and then to get the speed of the basketball, you can, it's the 88 joules, and we set everything up there. It's just we have to be careful with the algebra here because we have, the speed is squared. So take the square root of 282.05, should get 16.8 meters per second. So quite a bit faster, right, to be able to get the same amount of energy because there's so much, more mass for that bowling ball. Now we're going to take a look at this problem that is a 10-gram bullet, has a speed of 1.2 kilometers per second. And we want to find out what is the kinetic energy of that bullet, what's the bullet's kinetic energy if the speed is halved, and then what happens if the speed is doubled. So you can convert your grams to kilograms and your kilometers per second to meters per second, and then see if you can solve for each of those. And once you do that, you can continue. Okay, so for the speed, you should get 1,200 meters per second, mass of 0.010 kilograms, for an energy in part A of 7,200 joules. And then we can compare that to when the speed is halved. So when the speed is halved, we should get 1,800, should be joules, not new meters, for energy. And then for when it's doubled, we get 28,800 joules. And so if we compare how much energy the 1,800 is compared to 7,200, how much less it is, right? We take these two and we end up getting a fourth. It's 1/4 as much when the speed is halved. And then if we look at when the speed is doubled, 28,800 divided by 7,200 joules, it's 4 times as much. So but when the speed is doubled, and that's because the velocity here, or the speed rather, is squared, and so the speed has a major impact on the amount of kinetic energy that you have on an object. The second type of energy we're going to look at is potential energy, and that's the energy of position or configuration. So when we talk about potential energy, that's an object, at least with gravitational potential energy, that's an object over the ground that if it's released, has a certain amount of energy that can be transferred into kinetic, and so as it falls. And so there's a couple different factors. The mass, how much mass you have, is huge. The acceleration due to gravity, if it's Earth, it's g 9.8, and then how high, how high above the ground. The higher it is above the ground, the more energy it'll have. So this stored energy is the symbol can be used U or potential energy G. MGH is the potential energy for gravitational potential energy. Mass in kilograms, acceleration due to gravity meters per second squared, and then height above a 0 reference. So mass, again, in kilograms, acceleration in meters per second squared, and then height above a 0 point, which we're going to talk about now. For springs, we'll look at that later. Okay, so let's say we had an object, right, and we're holding it above the ground. Let's say the ground's here, and we have a certain height here, right? mgh. And then let's say we take this object and now we place it over here. What just changed was the zero reference. Now this can only fall this much. So this new mgh is going to be less because the zero reference is different here. And as we're problem solving potential energy, it's important to consider what's going on in terms of the energies. Let's say we have a boulder here that has a mass of 992 kilograms, and it's 42 meters above the zero reference here. Even though this is ground level, this is the zero reference. And you want to figure out how much potential energy does this boulder have. So we'll go ahead and pause the clip and calculate the energy of the boulder. Okay, so you should get 408,307.2 joules as the energy of this object. So a lot of joules of energy, a lot of mass, decent height. Okay, this is about 4 times the height of the stadium, 3.5 or so. So yeah, so that's the potential energy of that object.